Okay. See, actually, let's go to the. It is usually easier, right? To do the course in the web page, okay? Because within the web page we already have the code, we already have the result, right? So usually it is easier to, like, when I do explanation, I explain it in the web page, okay? And when we want to do practice, then we go back to the R Studio, okay? I say it again, okay? So usually I will do explanation. We just started, okay? We just started late. So usually I will do the explanation in the web page, and then when we want to do practice, we'll go back to R Studio, right? This is the way that we do things, right? The reason that I need to do indexing, operator, vector, and function again is because that they are, as I told you, that R is a casual language. Casual, it means that it's not very serious. It's not rigor, okay? It's not like an engineering language. So, well, casual is good because it's convenient, right? So you can do things in a lazy way, okay? But because it's lazy, there are some conventions, right? You will need to know. Otherwise, you will feel confused when you see that people write this and write that. There are some lazy way of writing R program, right? And for the beginner, it could be very confusing, right? So I would, in this 2 unit, I would like to go through a few very commonly used convention, right, in R, okay? So that for beginner you can like appreciate the convenience of R programming and don't get confused with it, okay? That is the major purpose. Yes. You will see what I mean by lazy way during this thing, okay? As I told you that this language is invented in Bell Lab, right? And I was there, right? At the time that they are inventing this language, okay? And the point is not to make another programming language. Right? The point is to build a convenient tool, right? So that we can do our daily computation in an easy way, right? And because we want to use this convenience, so there are some very funny, some very confusing convention you need to know. Otherwise, you will feel like, what are you doing? Like, yeah.
Professor, I see that in the RMB file,
yeah,
there are some HTML and CSS like a little bit. Like, do we need to learn the basics or?
Well, the CSS type of thing is like for the web page.
I mean, for the basics, like what we're learning now, is it just going to be like R, or should we also learn a little bit about HTML?
No, I don't plan to teach HTML in this course. Okay, so but if you want to do the HTML very beautiful, then you need to learn a lot of HTML format setting, right? But we don't have time for that. Okay, so that would not be our focus. Okay. Now go back to what we want to learn today, right? Okay, let's go to the notebook. Okay, so section 1 is for vectors and operators. Okay, so actually in R, most of the operator, when they act on vectors, they act on the vector's elements, right? Okay? See, when I multiply this vector with this vector, it is actually element-wise operation, right? So 1 is multiplied by 1, 2 is multiplied by 10, things like that. So most of the operator, when they act on vector, they act on it element-wise. Okay, so when that is element-wise, there will come a problem, right? What happens if the lengths of the vector are not the same? I mean, you do this multiplication element-wise, right? So what happens if the lengths of the vector are different? Okay. Sorry? You need to say louder, right?
It says that repeats it endlessly.
Yeah, you just repeat the shortened one. Okay. So for example, this one only have length 1, right? So it turned out that every one is divided by 10, right? Because this shorter one will be repeated again and again. Okay? So if you have only one element, then this element will be repeated 4 times. Okay? So if you had this is a vector of 4 and this is a vector of length 2, right? So which means that the 300 would be divided by what? So 100 divided by 10, 200 divided by 20, then 300 would be divided by 10, right? Yeah, because the shortened vector would be repeated endlessly until the longer one is finished. Okay. Sometimes you will see that this is the vector of length 8, and this is the vector of length 3. Okay. So it will give you a warning, right? It says that the longer object length is not a multiple of the shorter one. Okay, because this is 8 and this is 3. But even so, even that it throw out a warning, it still finish the calculation, right? It still finish the calculation, which means that the 1, 2, 3, you apply 1, 2, 3, 1, 2, 3, and then 1, 2, okay? At the very last time, okay? So I told you that if you try to do this in a rigor engineering language, it will not give you the result. It will simply tell you that it's error, okay? But in R, it's kind of like I told you that it's casual, right? It's just you try to guess what you want to do, right? And try to give you the answer. The good thing is you can do it lazily, in a laissez-faire type of thing. So. But the bad thing is if you are writing something wrong, you will need to be careful, okay? So check the result, okay, before you do the next step. So R is kind of like interactive things, right? So if you make a mistake, then you will see some unreasonable outcome, right? So check the output, make sure that it is reasonable before you do the next step, okay? That is the thing that I want to emphasize in this section, okay? Now in section 1.2, I'm talking about logical operator, right? This is mathematical operator, right? Mathematical operator. Now we are doing, what we mean by logical operator, we are talking about things like comparison, right? Okay. If you compare this vector, you compare 0.1 with 0, 0.1 is greater than 0, right? 0.2 is not greater than 1, right? 0.3 is not greater than 2. 0.4 is not greater than 3, right? So the result of this expression is actually a logical vector, right? Okay. So when we apply this comparison, this type of logical operator on a vector, the result would be a logical vector. Okay? You get my point? Okay. It's still like element-wise operator. Okay? Still operate element-wise, but the result would be would no longer be a numerical vector, right? When you do a mathematical operation on two numerical vectors, the result is also a numerical vector. But if you apply this logical operator on numeric vector, the result is actually a logical vector. Okay, so you need to remember that. So so here is a thing, right? This is one thing. And again, the shortened one are also repeated. Okay? Okay. So what happens if we do this? Okay, let's go back to RStudio and see. What do you say? If I do this, what would be the result? Huh? True, false? False? True, false? Anything else? True, nothing. Okay, that is another possible. So which one is correct? It's easy, right? Let's go back to RStudio, right? And let's come here. And then you press this button. You can see the result. It's true, false, right? Okay, so the rule that the shortened vector will be repeated also apply on the comparison, on the logical operators. Okay, so and there's a operator that the two equal signs like together. This is the test for equivalence, right? Two equal sign is different from one equal sign. Okay, one equal sign is an assignment, right? It's kind of like assign the right hand side, the result of the right hand side to an object name, right? So if you have one equal sign, then you're doing assignment. Okay, if you have two equal sign, you're actually doing comparison, right? You're comparing whether Amy is equal to Cindy, right? So in this thing, what would be the result? It would be false, true, false, right? Isn't it? Okay. And then there is another comparison operator which is also very, very important, right? It's the set comparison operator, which is, it is written in this way, okay? You cannot have space between this symbol, right? You need to be %, IN %. Just no space in between them, okay? This is one operator. And this operator is used for set comparison. You want to test whether these elements are within the set, within this set, okay? Okay? So you want to test, from time to time you want to test whether the element in one vector are also the element of the other one, okay? So this is kind of like, for example, Amy is not in this set, right? Bob is not in this vector. Cindy and Danny are, okay? So when you execute, you will see false, true, okay? Now, remember one thing. The order is not important in set comparison, okay? In a set, there is no order, right? Okay? So if I kind of like reverse the, if I reverse this vector, right, the result would be exactly the same, right? Because order is not important in this operator. Okay. But order is important if you are doing this. Okay? Order will be important in this type of, if you are testing for equal, okay, then actually it will be, you will have a different result. Okay? Let me show you. If I do this, okay, what will be the result? False, 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 false? Yeah, they're all false. But if I reverse order, what will happen? Yeah, you become false, false, true, true. See the point? Okay? So the difference between equivalent test and set comparison are different in a way that in set comparison, the sequence is not, the order is not important. Okay. Now we this 1.3 is the thing that you should already know already, okay, right? I already told you that 1 equal sign is different from 2 equal signs, right? Okay, and sometimes you can use this symbol is equivalent to 1 single equal sign, okay? I mean, you can write this for assignment. You can also write this for assignment. They are exactly the same, okay? In the old days, they used to use this symbol, okay? But myself, I tend to use this one, okay? It's shorter, right? But the things that you need to be careful, right? Because the equal sign is very different with 2 equal sign. Okay. Okay. So now let's go to section 2, which is function. Okay, a function call. Right. Now, if you have a vector like this, right, and then you want to calculate the sum of the vector, right? You already learned this function, right? If you call sum, the way that you have a function name and then parenthesis, right? This is a function call, right? And usually most of the function in R also works on vector, okay? For the sum is to sum the element of the vector. Min is to take the average of the elements within the vector. Things like that, right? So this type of function that transforms a vector into a single value is called, is sometimes called summary function, or sometimes called statistic function, right? Okay? The function that like take one vector as input and output a single value is sometimes called summary function or statistic function. So besides the sum and min, there are some medium, right? There's a function called medium. There's a function called minimum. There's a function called maximum, right? This type of function, they actually take a vector as input and output a single statistic, okay? So you have min, you have sum, you have like... Now, sometimes the function can have some arguments, right? For example, if you want to take log, the log has a base, right? You can have a neutral log. You can have log 10. You can have log 2, right? I mean, logarithm transfer, it actually has a base, right? So let me do it this way. So if I do log and 100, you see that it will be 4.605. Okay. So by default, the log function in this R environment, actually you can put the cursor on a function name and press F1. Okay. If you put the cursor on a function name and press F1, you actually see an online help in here, right? So it tell you that this log function is like x is actually the input, right? So if I do log 100, then x is what I want to apply log, and that this is the base, right? So the base is actually exponential 1, which is the natural log. Okay, so by default, so this function actually has 2 arguments. Okay, but the second argument has a default. Okay, and it default to natural log. Right. So as long as you want to use the default, then you don't need to. As long as you want to use the default, you don't need to put on the second argument. Okay, you just type. Right, okay. But if I want to use the 10 base log, right? Especially in business, we used to use the 10 base log, right? So like, let me. Okay, so I can do this, okay? Because it's log 10, right? So 100 turned out to be 2, right? 1,000 turned out to be 3, isn't it? Right? Okay. So this is what I mean by lazy, right? Okay. If you accept the default, then you don't need to worry about the second argument, right? Now, if you want to change the default, then you can always type in the default. Okay, right? So when you call a function, if you don't need to worry about some function has a lot of for example, like the sort function. You can see that the sort function has a lot of actually has a lot of arguments, right? Okay, but for most of the argument is already have a default. Okay, so if you accept the default, then you don't need to worry about the rest of the arguments. Just throw in the input vector, and then you would apply the default on it. If you want to override the default, then you need to specify the default. Okay, and when you specify the default, well, formally you should write it in this, okay? Because this is the first argument. Let me do it again. See, the first argument is called x, right? And the second argument is called base, okay? So formally, if you want to call log, you should say x equal to 1,000, base equal to 10, right? Okay? But in R, I told you that it's lazy, right? So if you do this argument in order, right? In the sorry, you don't need to type in the argument name, okay? I mean, the first one is x, the second one is base. Even you do not type in the argument name, it will accept the call, right? But for some reason, if you want to do that, okay, sorry. If you want to within the parentheses, if you want to place this argument in an order that different from its definition, right? Then you do need to include the argument name, okay? See, it's the same result, right? Okay. So this is function call and argument, right? In function call, you need to you can use F1 to see all of its arguments. And actually, most of the argument has a default, right? If you want to override the default, and if the default happens to be the second one, right? If the one that you want to override happens to be the second argument, you don't really need to type in the argument name, right? As long as you call the function in the sequence, you give the argument as the same order in its definition, okay? That's what I mean by casual and lazy, right? It gives you a lot of convenience, but you need to know this convention, otherwise it would sometimes get confused, okay? As I explained here, right? Okay. So this is my notebook, okay? So I basically will try to besides the code, I will tell you what is the point, right? What is the point? Right? Okay, the last thing that I would like to explain is this pipe operator, okay? There's a pipe operator that you can use, okay? Sometimes we would like to do a thing like this. I have a x. This x could be a vector. It could be a single value. Okay. So in this x, I want to apply a square. I want to take the square root on x, right? And then I want to do a log 10 transformation. And then I want to do a mean. Okay. I want to do a average. Okay. So actually, if x is a single value, it makes no sense to apply mean, because, okay. So but the point of if you write program like this, right, it's very difficult to read, right. See that you have parentheses after parentheses after parentheses, right, and it's kind of very difficult to see what you really want to what you really want to do is things like this, right? You want to take the square root of x, right, and then do a log 10 transformation, and then do an average, right? So this syntax is exactly the same as this syntax, okay? They are equivalent, right? But this syntax is easier to read, okay? So sometimes when we want to call a series of code, right? You don't want to like put a function code within a function code within another function code within another function code. That would make it very difficult to read, right? So in that case, this pipe operator would be very handy, right? The way it works is it would actually like when you have this pipe operator, it simply take the left hand side as the first operator, as the first argument of this function, okay? Which means that you will put this square x as the first argument of log, okay? And you would actually use the log as the first argument of mean. See that? Okay? So in this way, you can actually chant a few functions together, right? In an intuitive way, right? You don't have to like, if you write it this way, it kind of like reverse, right? It kind of like reverse our intuitive thinking, right? So this pipe operator is make it easier to chant several function code together, right? So this is the last thing that I would like to explain in this notebook. Okay. So any question up to now? No? Okay.
If the function call is using the pipe operator, if it got too long, is it okay to use a new line, or will the new line be a different function
Good question. Let's see. Okay, as I say, if x is kind of like 10, okay, can you you know this, right? I put 10, the first, I erase 10 to the first, second, third, to the fifth order, right? So it's like 10, 100, 1,000, right? So x equal to this vector, and I want to do this. Okay. So the question is, actually I can do it this way, right? I told you that we call this pipe, right? Okay. If I pipe x into square, then x will become the first argument of square, right? So if I execute this, if I select this and I press Control Enter, okay, yeah, it would. This is the square x, okay. This is square x, and then I want to do a log 10, and I want to do a min, right? Okay. So if sometimes the function, the question, if sometimes the question is too long, right? And I have to like, and I have to do this, right? Now see what would happen. If you put the cursor here, right? And you press Control Enter, it would actually execute the 3 lines together. Okay. So this R environment, it is pretty smart, right? If at the end of the line, it figured out that the expression is not finished yet, right? For example, at the end of the line, you see that there is a pipe, right? So there must be something behind the pipe, right? So it figured out that this line is not finished yet, okay? So it will look into the second line. And then you figure out that the second line is not finished yet, right? So you will look into the third line, okay? So so at the end, when you put the cursor here and you press Control Enter, it will execute the 3 lines together, okay? So in this way, you can actually like do a pipeline like this, right? You can do a pipeline like this, right? It's kind of like I have an input x, right? And the first step is I want to take a square root. The second step is I want to take a log 10 transformation. And then the last step is I want to do a average, right? So it's kind of like a data pipeline, isn't it, right? So you can write the pipeline in this way, or you can do it in a compact way. The result would be the same, okay? That answer your question? Okay.
In the same case, if we do not end with the pipe operator.
Sorry?
So in the 3 lines,
Yeah?
you just showed, all lines ended with a pipe operator.
Right?
But if you put that same operator below, then it will only execute the 4th line.
Yeah, good question. If you do this, right? If you do this, then when you do the execution, it will only execute this. Because at the end of the line, you already see a complete expression, right? Okay? So the point is to make it incomplete. Then it will continue. See the point? Right? Okay, so this is the first notebook. Okay. Now let's go to see the second notebook, which is the index RMD. Okay. click is the index IMD, and well, and you can knit this RMD. Actually, index you already learned, okay? You already learned a lot of indexing in your homework assignment, okay? I just want to give you a systematic, because indexing is very important, right? In programming, because data objects are complicated, right? And when you are looking into this composite data object, vector data frame, right? From time to time, you're using index very, very often, right? Okay, so in your homework, you already exercised the using of index, but I want to give you kind of like a systematic, I want to give some holistic understanding of what index really is, okay? So let's try to do that in an example, right? Okay. For example, you have some vectors, right? This is customer data, so you have 5 customers. This is the frequency, which means that this is the number of time that they buy from you, okay? And this is the amount, perhaps the average amount that they buy from you, okay? And then this is whether the customer is a member, right? This is the customer's name, customer's gender, and also sometimes they have class A member, class B member, right? Okay, so you can put the attribute of your customer in the vectors, right? And you define the vector. The vector are of the same length, right? Lengths are 5, but they are of the same class because they are all vector, but they are of the different type, right? First one is the integer vector, numeric vector, logical vector. Right? You have all kinds of vectors here. Okay. And then you can do index, right? If you are interested in from time to time we want to select some customer and do calculation, right? In some criteria, okay? So you have basically 3 ways to do indexing, okay? In your when you are doing the vector section, you actually already it actually already teach you how to use these 3 types of index. I just want to reiterate it again, so you have a better idea about what index really is, right? Yes.
In your example, I want to ask, why do you use s dot factor instead of factor? Why do you use the function s dot factor instead of factor?
Why do I use
S dot factor instead of factor.
Let's define some vectors.
which line?
Let's define some vectors in gender and class. You've used the AS as
Oh. S factor is exactly the same as factor. So they are like, this is the old way to, conventionally, you need to say S factor. But now you don't need to do that. So S factor is like exactly the same as factor. Okay? So you can remove it. This is the old way to write to define a vector. Okay. Now, if I want to take the first and the fifth position out of frequency, right? This is the way to do it, right? So you can see that in R we use the angle basket, right? We use we use this symbol, right? The angle basket to do indexing, right? And if now and the index by itself, this index by itself, as you can see, it is an integer vector by itself, right? Okay? If you want to index by position, okay? because you want to know the position, and the position is by itself an integer, right? So if you index by position, you basically use right, within the angle basket, you actually need a integer vector, right? And the integer vector, the length of the integer vector depends on how many elements you want to select, right? Okay. Okay. So this is pretty straightforward, right? Okay. So index by position is straightforward. You basically put as I can demonstrate here, you actually can define an integer vector, right? And use this index, right? You use this vector to index among, okay? From time to time, when the index is very complicated, sometimes you will have to construct the index first, and then apply that index into the targeted vector that you want to index it. Okay, so for this example, I want to use position 1, 2, 3, and 5, right? So I define the integer vector in I, and then I apply I as an index to among. Okay, then you will grab out this index. Okay, and then so you can use index to select, to reproduce, right? So sometimes you might want to do that, right? 1, 2, 2, 3, 3, 3, 4, 4. It means I want to repeat the second element twice, repeat the third element 3 times, and repeat the fourth element for whatever reason, for some reason, right? So if you want to do that, you can do this, okay? And the result would, like, the first element would repeat once, and the second element twice, things like that. You can also reorder the elements, right? For example, if I want to reverse the order from 1, 2, 3, 4, 5 to 5, 4, 3, 2, 1, you can do that. Okay? So using the position operator, usually you want to, like, do some reordering type of things. Okay? So you would do the index by position. And the other thing is index by name, right? Okay. If you still remember your homework, there is a relate vector, and there is a die. What was it?
Poker vector.
Poker, yeah. There's a poker vector. There's a relate vector, right? And you can actually name the vector, name the element of the vector by weekdays, right? Monday, Tuesday, Thursday, right? Okay, so the R object, if it was a composite object like vector, you can actually assign a name to each of its element, right? Now, if the element has a name, then, for example, you can assign name in this way, right? You assign name to this among vector. So in the beginning, the among do not have names, right? You use, in the beginning, the among do not have name because you define it this way, right? So in the beginning, among do not have name. But you can assign name to among by doing this, right? By calling names among and then give it the character vector, right? So after doing that, among, every element of the among has a name, right? As long as every element has a name, you can use a character vector to index among. See? Okay? Okay? As long as the vector has a name, right? I should say that as long as the element of the vector has a name, right? Then you can use their name as an index to select element from the vector, right? This is called index by name. So index by position is actually indexed by integer vector. Index by name is actually indexing by character, right? Character vectors. But the most important type of indexing is actually what we mean, what we say logical or conditional index. Okay. Now let me in its form, it's like you are using true false. Okay. You can use T for true, right? F for false. Capital T and capital F is true and false. Okay, in R. So you can use a logical vector, and this logical vector need to have the same length. Its length has to equal to this vector, right? If you want to use a logical index, the length of the index need to be the same as the vector itself. Okay? Because it need to be true false, right? And you want to choose the true one, and you don't want to choose the false one, right? So the vector of the true false, the vector of the logical vector, need to be the same length as the vector that you want to operate on. Okay? And this is very useful because of, for example, if I want to use this logical vector, you can actually select element by condition, isn't it? For some reason, if I want to choose the element, if I want to choose my customer with frequency, with buying frequency, no less than 2, right? Okay, then I can write a logical expression like this. You see that? In business, this is the most useful way to use index, right? So the most useful way in business analytics to use index is to use logical, or I should say conditional index, okay? So the index by itself is generated by a logical comparison, right? So it's kind of like a condition, right? You have like, in this case, we only have 5, right? In a real case, you might have like 20,000 customers there, right? And you only interest in like male and you have some condition, right? So you want to select this customer by condition, then you are using this logical index, okay? And the logical index is by itself kind of like generated by a thing like this, right? So this is the most useful way, okay? The most useful way of doing indexing, okay? So we have 3 ways of indexing, okay? Index by position, index by name, and also index by condition, okay? So, and the last one, index by condition, is the most useful one in business analytics, okay? Now let's take a break and let's go back to the course in 10 after 11, okay?